Hi friends, this is Gautam. In this video tutorial, I am going to discuss about traceroute concept. Let's see. So traceroute is a one kind of troubleshooting method. So we can use it to figure out the issues in our network. So like ping command, we are used to check the issues in our network. So normally if particular device is reachable or not. So we can check through the ping command. Same like traceroute also one kind of troubleshooting method. So ping command is a bit limited sometimes. So for an example, this is my example scenario. Here I am using 4 routers and 2 PC. So router R1 is connected to PC1 and router R4 connected to PC2. So PC1 IP is 192.168.100.1 and PC2 IP is 192.168.200.1. So now I am trying to ping from PC1 to PC2. So my ping getting failed. I am not able to reach PC2. So here if I know the IP address between the R1 and R2, R2 and R3 and R3 and R4 means I can able to ping that IP and I have to troubleshoot that issue. So in case the IP I don't know, so between R1 and R2 I don't know that IP address, and R2 to R3 also I don't know the IP address, and R3 to R4 also I don't know the IP address. So in this case how we can troubleshoot? So using traceroute we can figure out the issues. So just go to the PC1, you have to give traceroute and you have to give the destination IP. So the packet will going via R1 to R2. So the entire path will be showing. So exactly where the packet getting dropped, so you are not getting that entry. So from that we have to figure out the issues. So what I discussed in the previous slide, that one only I mentioned here. So when we send a ping from PC1 192.168.100.1 to PC2, so the ping does not work. What does it mean? So well known something is not working, but we don't know whether the problem is in between. So R1 to PC1 or R1 to R2 or R2 to R3 or R3 to R4 or R4 to PC2. So we don't know where the issue is exactly. So if you know the IP address means, if you know the IP address of all the routers means, we can ping that IP address and we can check it where the issues is exactly. So what if you have no idea how many routers are in between, or if you don't know the IP address? For example, if you don't know how many routers in between PC1 and PC2 and also you don't know the IP address, in that case how we can troubleshoot? So through the traceroute, what I discussed in the previous slide, so will help us with that. So here's a quick example. So from my Windows laptop I'm trying to ping the try to trace route the cisco.com website. So this is the output. So first entry is my router gateway, then afterwards in between nearly 20 routers are there. So after 20 routers it will reach the cisco.com web server. So here you can see trace completed. So here it will showing that device name as well as the IP address. So above I used traceroute command on Windows computer to trace the path from my computer to the cisco.com. So you can see all the IP address and host name of the routers in between my computer and the server that responds to www.cisco.com. So response time that you see is a round trip time from my computer to the router for each router. So traceroute sends 3 probes. So each and every time traceroute will send 3 packets to the single hop. Okay, so now we know what is the use of traceroute. So here how does traceroute works? So traceroute uses TTL value, that is a time to live field in the IP packet header. So you saw my previous video session means you can able to understand this one in IP packet header. So we have the TTL value. So each and every time the router receive the packet and forward to the next router. So before forwarding it will reduce the TTL value 1. So normally TTL is used to prevent packet from being forwarded forever when there is a routing loop. So whenever IP packet is forwarded by the router, the TTL is decreased by 1. And the TTL is 0 means the router is right away the packet IP packet will be discarded. Okay, so again we are taking the same example. Now here we can see how the trace route is used. So let's look at the example. Let's say that PC1 is 192.168.100.1. We send a trace to PC2, that is 192.168.200.1. So the first packet the PC1 sends will have a TTL of 1. So first PC will send a packet with the IP packet with the TTL of 1. So the packet reached the router tried to forward that packet to R2. So before forwarding it will reduce -1. So now TTL value is 0. So immediately router R1 dropped that packet and sent TTL time exceeded message to PC1. So next one again, now PC1 try to send the IP packet with TTL value of 2. Now the IP packet received by the R1 router, now it's forward to R2. So before forwarding to R2 it will reduce -1. Now the TTL value is 1, is sent to the R2 router. So R2 router tried to send to R3. So before sending it will -1. So now TTL value is 0. So R2 router drop right away, and it will send the time to leave time exceeded message to R1. So R1 will decrease the TTL from 2 to 1 and forward it, and now R2 has to drop it. R2 will respond TTL exceed message. So PC1 will now send another IP packet with the TTL of 3. So now the packet received by R1, then R1 is forward to R2. Before forwarding it -1. Now the TTL value is 2. R2 received that IP packet and is reduced the it will -1. The TTL value is 1 and forward to R3 router. So R3 router is tried to forward R4. So before forwarding it will -1. Now the TTL value is 0. So R3 router drops the packet right away, and it will send the time to leave time exceed message to R1. So PC1 will now send another IP packet with the TTL of 4. So again the IP packet received by router R1. So before forwarding to R2 it will -1, and then afterwards R2 router receive the IP packet, and before forwarding R3 it will -1. The TTL value is 2. Now R3 router receive the IP packet. Before forwarding to R4 it will -1. So the TTL value is 1 and it's sent to the R4 router. R4 router tried to send that packet to PC2. So before sending PC2 it will -1. So the TTL value is 0. So immediately R4 router drop that IP packet and send time to leave exit message to R1 router. So that one only I mentioned in this point. So now R4 send the time to leave exit message to R1. So the last packet that PC1 will send will have the TTL value of 5. So now the TTL value is 5. The PC1 send that IP packet to R1. R1 -1 and it forward to R2. So TTL value is 4, and R2 router forwards to R3 and TTL value is -1. So TTL value is 3, and R3 router forwards to R4. Before that -1 TTL 2, and R4 router forwards to PC2. Before that -1. So the TTL value is 1. Now the PC2 receive that packet and reply to that packet with ICMP reply. So each router decrease the TTL by 1. Our PC2 on the other end will receive the IP packet with the TTL of 1 and reply with an ICMP reply of to PC1. So we know the destination is reachable, and we learned all the router in our path. So each IP packet that we send is called probe. So probe means each IP packet we can send, that one only we can call as a probe. So Traceroute can be used with ICMP, UDP and TCP protocol. So depends upon the operating system. For example, if you are using Windows operating system, you are going to trace some destination IP means, so that time backend it will be running on ICMP. In case if you are Traceroute something from the Linux OS means, that time UDP will be running on backend. So it depends upon the operating system. Okay, so now we can see the real-time example. I will use the following topology for this demonstration. So R1 to PC1 in this network I am using 192.168.100.0/24 network, and R1 1 to R2 I am using 192.168.12.0/30 here 1 and 2, and R2 to R3 I am using 192.168.23.0/30, and R3 to R4 I am using 192.168.34.0/30, and R4 to PC2 I am using 192.160.200.0/24 network. Okay, so above we have two hosts. So PC1 is a virtual PC. I'm assigning 192.168.100.1, and PC2 is a 192.168.200.1. So the router I have configured EHRP routing protocol. So there is a full connectivity between PC1 to PC2. Okay, from PC1 I am going to traceroute 192.168.200.1. So the traceroute is completed. So before I'm giving the trace command, I have to capture the packet through Wireshark. So I will show it to that output to you. So above we see all the routers and the destination. So for each hop, Traceroute will send 3 IP packets. So each and every time the PC will send an IP packet, it will send 3 times. So that one only I mentioned here. So we do this to get a good average of round trip time for each hop. So each and every time we are sending 3 packets to next one hop. So we have to get good average of round trip time from that each hop. So let's see what IP packets look like in Wireshark. So this is the first packet trying to the PC1 IP is 192.168.100.1 and destination IP is PC2 IP. So the TTL value is 1. So immediately after receiving that router, before forwarding to R2, it will minus 1. So now the TTL, time to live, is exceeded. So it will send that message to from R1 router to PC1. So 192.168.100.2 is a R1 router IP and this is a PC1 IP. So now again PC try to send another IP packet with increase the TTL value to 2. So source is PC1 IP and destination is PC2 IP. So now R2 router receive that packet and try to forward to R3. So it will minus 1, the TTL value is 0. So R2 right away drop that packet. So here we can see 192.168.12.2 is a R2 router IP and this is a PC1 IP. So here we can see time to live exceeded. So now again PC1 try to send another IP packet. Now the TTL value is set as a 3. This is a PC1 source IP and this is a PC2 as a destination IP. So now 192.168.23.3, so 23.2. So this is a R3 router. So now R3 router try to forward to R4. Before forwarding, it will reduce the TTL value minus 1. Now the TTL value is 0. So immediately R3 router drop that packet and send time to leave exit message to PC1. So this is a PC1 IP address. Okay, again the PC1 send an IP packet. Now the TTL value is set as a 4. So this is a source IP is a PC1 and destination IP is a PC2. So now R4 router. So R4 router send and time to live. So R4 router try to send to PC2. Before sending minus 1, the TTL value is 0. So R4 router right away drop that packet and send time to live exit message to PC1. Then last packet, finally the PC1 set the TTL value as a 5 and source IP is a PC1 and destination IP is a PC2 IP. So the packet reaches the PC2 and PC2 reply to the PC1. Here we can see source is 192.168.200.1 is a PC2 IP and 192.168.100.1 is a PC1 IP. So PC2 reply to the PC1. Now the trace is successful. Okay friends, so I hope you liked this video. So if you have any queries, please reach out to me and please share your comments with me. Thank you friends. Thank you for watching my video.